So what we have here is another series. So we're going from n equals to 1 to infinity. And we have 5 raised to the n times n squared over n factorial. I don't like the factorials. But once I learned the ratio test, I was just immediately like, I was like, okay, this is good. I like factorials because when we have the ratio test, factorials work really well. They cancel and it's very satisfying. It's very nice. So let's go ahead and see if start off with the divergence, right? Let's start with the divergence test. Take the limit as n approaches to infinity. I'm going to tell you now that this is not going to help you. So spoiler. This will be 0. This is not going to help you because this is going to get larger faster than this, which is kind of a way that you can obviously determine that it's going to be 0. Okay, so the next thing is to start with the tests. I'm not going to go through all the tests now because I told you in the beginning that whenever I see a factorial, I get excited. And I'm like, okay, this is going to be the ratio test. So let's use the ratio test. The ratio test goes like this. So if you have the limit, you're going to take the limit as n approaches to infinity. I'm just writing out the formula. So it's a sub n plus 1 over a sub n. If this is less than, so okay, let's first write this. So if this is what you need to take. First of all, if this is less than 1, we are convergent. And actually it's absolutely convergent, but I'll just write convergent. Then we have the limit as n approaches. So this is first case, this is second case. If this is the limit as n approaches to infinity of a sub n plus 1. Of course, a sub n is this thing here. So that's a sub n plus 1 over a sub n. If that's greater than 1, then we are divergent. And the last case, of course, is what's left over? Well, if you're equal to 1. A sub n plus 1 over a sub n. If it's equal to 1, then we are inconclusive. This doesn't help us. So know this. These are the 3. This is like the ratio test. You should have this in your head, in your notes, whatever. This is important. This is essentially what the ratio test tells you. So let's keep that in our head and move on. So let's take the limit as n approaches to infinity of, so this is a sub n, as I said before. This is a sub n, which is 5 raised to the n times n squared over n factorial. And a sub n plus 1 is 5, so just add 1 to the n's. 5 raised to n plus 1 times n plus 1 squared over n plus 1 factorial. Right? Just double check. Okay, good. So, okay, a sub n plus 1 is, and again, we have to take the absolute value. I don't know if I wrote it before, but this is the absolute value. I might have just written this, but instead what I meant was this. So if I wrote this, I don't know, but if I wrote this, it's the absolute value. Okay, so keep that in mind. So this is going to be the absolute value, and that's why we can say absolute. We can conclude absolute convergence if it's less than 1. But yeah, let's just keep that in mind. This is going to be 5 raised to the n plus 1 times n plus 1 squared divided by n plus 1 factorial, divided by this business here, a sub n, which is 5 raised to the n times n squared over n factorial. So, okay, whoops. This now is what we have to solve. Let's try and, okay, so first of all, do we need these absolute value bars anymore? We don't, because as we get larger and larger, we're actually not going to be negative anywhere. We don't have to worry about it. And I don't like absolute value bars that much, to be honest. So I'm happy that we can remove them. So 5 raised to the n plus 1 times n plus 1 squared over n plus 1 factorial. And then I'll multiply by the reciprocal. You should know how to do this stuff. This is basic algebra. So 5 raised to the n times n squared. But if you need a review, you can always review. That's sometimes you need a review. That's fine. So okay. Now this is where I said that the cancellation occurs. Let me go ahead and rewrite this. You should know how to do this. Okay. 5 raised to the n plus 1. This is your exponent rules. This is equal to 5 raised to the n times 5. This is your exponent rules. If you need review, go ahead and review. I will not be talking too much about it, but it's important to know. This is going to be n plus 1 factorial. Now this is, again, your factorial rules. This is n plus 1 factorial, which is equal to n plus 1 times n minus 1, etc. So let's write that out. N plus 1 times n minus 1, ... But this business here is essentially n factorial. Think about that. Because this is n factorial is n times n minus 1, ... which is what we have here. So that's why this is n factorial. Let's rewrite that as n factorial. N factorial multiplied by n factorial divided by 5 raised to the n times n squared. That's what we have. Now, the cancellation process. This is the satisfying part. This is gone. This is gone. Factorial's gone. We have no more factorials. That's great. I don't like factorials, as I said before. 5 raised to the n, 5 raised to the n. Even the variable exponents are gone, which is great. That's great as well. And I just realized that I was writing b approaches infinity, but this is supposed to be n approaches infinity. I solved the problem before with b, and so it's just stuck in my head. But it's n approaches infinity. Notice that the cancellation really simplifies everything now. So we can write this limit as n approaches to infinity of 5. So let's just write what's left over. 5 times n plus 1 squared divided by n plus 1 times n squared. Okay, so this is left over here, and this is left over here. There. All right, what's this going to get you to? Another cancellation occurs here. Just notice that. N plus 1 and this. That's gone. So this ends up getting limit as n approaches to infinity of 5n plus 5. I just distributed this in. And then all over n squared. Beautiful. Beautiful. This, let's just make it easy for ourselves. You don't have to think too much, although you should have the answer by now. But this is going to be 5n over n squared. If you don't, that's fine. This makes it much easier for us. Limit as n approaches to infinity. This n and this 2 cancel, so it's 5 divided by n plus 5 over n squared. Okay. This goes larger and larger. This becomes 0. This goes larger and larger. This becomes 0. So we end up with 0. This is good. This is not equal to 1, which tells us so much. This tells us this is very good. This is a happy moment because we did all this work and it proved to be useful because 0 is indeed less than 1. You should know that. 0 is less than 1. If you don't know that, review your number line. 0 is less than 1. So 0 is less than 1, which tells you that this is actually absolutely convergent, which is stronger than just convergence, but we don't care. We just want to know convergence or divergent. So this is convergent by the, so I'll write that up here. This is convergent by the ratio test. Beautiful. This is your conclusion, and this proves convergence for this here. Hope you found this video helpful.